Good morning, good afternoon, and good evening, everyone. My name is Nate. I also go by Hockey Boy Nate, and in this video, we're going to be discussing the potential for severe weather in the mid parts of next week. Before we get started, please be sure to leave a like, subscribe if you're new, and press that notification bell button so that you can be updated with all sorts of content, whether it's these videos about forecasts or the live streams that I do for live severe weather analysis and arguably the best severe weather analysis on YouTube, as well as sharing it with friends and family so that people can be up to date. Let's get into it. We'll take a look here at the Storm Prediction Center's website here, and just by looking at their forecasts, it seems as if for the next few days, there is absolutely nothing going on. I mean, you take a look here at the severe weather characteristics here, the bar here that tells us if there's anything that's going on. That's a white that's a white epic pen. That's not very good. Look here, no severe for the next 3 days. I know you can't really tell because my face cam's in the way, so I'll actually move it up just a little bit. Take a look there. You can see no severe for the top parts. So the next 3 days, according to the Storm Prediction Center, it's going to be pretty much so dead. But believe it or not, there actually is some severe weather on the horizon, as I mentioned yesterday in the video we had here. But the reason being why everything's kind of relaxed is because of that warm-up that I was talking about, which if you want to go see that warm-up, the link will be in the description down below. We'll be talking, well, it was in yesterday's video, where we were talking about how much of the country is going to be warming up before we get into severe weather. But speaking of severe weather, let's take a look at that. The GFS model, the global forecasting system, which, by the way, in my opinion, this model is the best at what it does in regards to precision as to where systems will be, especially since it gets constantly updated by the National Weather Service, whether it's its forecasts or its live weather stations across the board. So I really do trust this model the most out of all other models, which is the reason why I use this model the most. But if we take a look here, you can see the first bits and bobs. It's exactly what I was saying yesterday. Nothing's happening. It's Sunday right now, Monday, Tuesday, all the way up into Wednesday, where we start to get something here, this low pressure system that forms off of the Rockies, and that'll push off into the Midwest, into the parts of Wisconsin, Minnesota, Iowa, even Michigan. And this is where we can begin to see our severe weather. Remember, guys, Wednesday, March 10th, this is the day in which we will be looking at for severe weather. As it continues to move on forward, you can see that low pressure move on through. You can see snow that'll form across parts of the northern plains, and maybe even some isolated precip along the areas near Duluth, and some scattered showers along near Minneapolis. But this is where things get really interesting. This is the morning, and as it gets towards the evening, you can see the afternoon hours. You can already have a line forming across parts of Kansas and Oklahoma going up into Missouri. And if we advance just one more frame, you can see this line extends all the way down from that low pressure system. So this cold front right here is really giving off this cold fronty vibe, especially since with all this cold air being plunged into and behind this system. And you can see that by all the snow that's up into parts of Minnesota. But this line right here, this line that extends into Kansas and Oklahoma, is what we are going to be watching very closely. And the thing of it is, too, is if we go over to Pivotal Weather real quickly, which, by the way, I love Pivotal Weather. I've had Weather Bell since the beginning of last year. Don't really know how to react to it, but it's fine. It's okay. But Pivotal Weather, for it being free, is definitely well worth it. So if you ever want to look at models and stuff like that, if you're a weather enthusiast, go to Pivotal Weather. I like it a lot. But what we're looking at right now is we're going to be looking at a model trend. And what this is going to tell us is this is going to look at the different model runs over time, and we're going to be able to see if there's kind of a pattern here, if we can be able to determine if there's going to be the likelihood of severe weather or any sort of activity within a span of a couple days. So let's take a look here. This is the furthest out that a model run was, which was on the 3rd of March. And you can see this low pressure, it has it all the way up into Canada, and you have this line moving through into the Midwest. But we'll see as it continues to move on forward a bit more and a bit more. You can see the low pressure actually moves a bit further west. And look at this. Look at this. This is March 4th in the morning. And you can see this line extend all the way down into Kansas and Oklahoma. It looks eerily similar to what our latest run was on Weather Bell over there. So that's really interesting, especially since with a couple of days out like that, you know, a couple of days behind, it already said that we'd have this line. So let's continue to look through and see if anything really changes all too much. Well, actually, we'll create a line right here. Not a good placement of line. We'll create a line right here, and if it goes past this line, then it's kind of a bit wonky. But still, let's go forward. You can see it stays right on the line, and look at that. Look at that. Actually, it stays relatively the same right within that area. So we can safely say that this area right here will get some sort of thunderstorm activity. And the thing of it is too, is if we quickly want to take a look at the supercell composite, which is just a mixture of all sorts of characteristics. It takes in dew points, it takes in wind shear, it takes in energy, CAPE, as some people like to say, which we'll discuss into how to look at CAPE later on in the video. We'll take a look at the supercell composite, which will be able to tell us the likelihood of supercells being, well, not really the likelihood, it would be an indication as to how strong a supercell could be. And so we'll take a look a bit further here, and you can see by that Thursday morning, you can already see a little ball right in the southern parts of Kansas, northern parts of Oklahoma. And as it continues to move on forward, ooh, it already starts to get into the blues. And typically that's from 5 to 10, which is not bad for this time of year. And look at that. It stays there. It actually uptrends a bit. Look at this. You get a larger area of blue, and it still stays within this general vicinity. Northern parts of Oklahoma, southern parts of Kansas. Now, real quickly, I do want to take a look at that little ball here on the latest model run, and you can actually see a little bit of yellow here. Just a little bit. You might not be able to see it, but if you squint hard enough, you might be able to tell. If I hover over it, that says 10. That's a supercell composite of 10, which is double digits. So that's actually not that bad for this time of year, especially since it's early March and severe weather season usually doesn't start until mid to late March. I mean, it is the 11th, so if you want to count the 11th as mid-March, then you can go right ahead, but it's still relatively early into March, and we're getting tens of supercell composite, which is pretty good. But we'll take a look here, and we'll be able to see the sounding here, which if we're just taking a look at the sounding, or if you want to know what a sounding is, basically imagine someone getting a weather balloon and lifting it up in the sky. The people, whether it's at the National Weather Service or at the Storm Prediction Center, then measure where the weather balloon is going and also the conditions around it. So in this case, we'll take a look at the hodograph first. And if you can just imagine being in a satellite and you're watching that weather balloon go up, down, left, and right, loop-de-loop, whatever, you can just imagine, the trajectory that it takes. This hodograph represents that. So the weather balloon goes up, and then it turns right, and it keeps turning right, and then it goes down, and it goes up and around, and has a whale of a time. And why we do this, why we look at hodographs, is so that we can be able to determine if it has a chance for producing tornadoes or being tornadic, or even in general just forming supercells. And in this case, you can take a look here and you can see that this does curl off to the right, which does create a bit of spin in the atmosphere. And usually when you see winds veer off like that, it tends to create that tornadic motion. So this does check out. This is a tornadic hodograph. You can even see that here. I don't use the possible hazard type, but it does indicate tor, or short for tornado. So something to keep in mind with that there is that hodograph is checking out as a tornadic hodograph. Let's take a look at the convective aspect of it though. And if you guys look at this, if you guys are new and you look at this hodograph, you can basically just see a bunch of squiggly lines. You'll probably see a bunch of these little sticks and stuff like that and be like, all right, that's it. I'm done. I'm not messing with that. But no, that's, believe me, it's actually a lot easier than you think it is. Trust me. And the reason why I say that is because if you take a look at the lines specifically, I'll actually zoom in here a bit. Still zooming in, and we'll move it over to the side. You can take a look at this line, and you'll be able to see at the bottom of it, you see this red number with an F, and that's actually 68 degrees Fahrenheit. So it tells you right here what the temperature is at the bottom, which means that this red line right here indicates temperature. And as it goes up and up, that indicates at taller heights, at higher heights, that's a word, then that's the temperature at those specific heights. So for instance, right around here, this is 3 kilometers. And if we were to look at the temperature line, you can see how this dotted line kind of goes across. Right at about here at 3 kilometers is 0 degrees Celsius, which down here, it's kind of weird because this right here is all Celsius, but it says Fahrenheit right here, so it can easily get confused. But 0 degrees Celsius, which if you translate that, that is actually 32 degrees Fahrenheit. So as it goes up and up more and more, you can tell the different temperatures with this red line. This green line, however, you can still see, well, it's 57, but it's Fahrenheit. Well, in that temperature? Well, kind of. There is another thing that is represented in Fahrenheit, and that is dew points. So dew points is useful because that measures the moisture in the air, and as it goes up and up, you would typically be able to see this kind of moisture line as to how moist it is up in the atmosphere. Moisture is pretty good because the more moisture you have, the more energy there is for thunderstorms. So just keep that in mind. It measures the amount of moisture in and around those areas. But there is a couple things that we still need to look at. And one final thing that we need to look at is this dotted line. This dotted line, and hear me out, it's going to sound really, really weird, is a developing parcel line. And what that means is if a thunderstorm were to develop, just pop out of existence, typically you would see clouds rise up, right? It would shoot up like a giant mushroom cloud and then spread out. That's exactly what we're seeing here as to what the thunderstorm would take in order for it to develop into a stronger thunderstorm. So, as we look at this developing thunderstorm line, as well as the temperature line, this can actually indicate how much energy there is. And the energy that it stands for is CAPE, or convective available potential energy. So the more CAPE there is, the stronger the thunderstorms are typically, and the more energy there is for the thunderstorms to sustain. So remember, CAPE can also help thunderstorms develop. It can also help thunderstorms sustain. So if we take a look here, anything that is in between this dotted line and the red line right here, all of this is CAPE. And you can actually see that. You can't really see it right here because it's a bit in the way. My face is in the way. Gotta get my big face out of the way. You can see that right here. This right here is CAPE. So at the surface, or SFC, that's 1,282 joules per kilogram. The forecast CAPE in that area is 1,647 joules per kilogram, which is pretty interesting, especially since in order for you to get thunderstorms that could produce tornadoes, I would typically like to look at around 750 to 2,000 joules per kilogram at minimum. All right, there's some instances to where even if you get that amount of CAPE, you don't even get tornadoes because the mode is not correct. The hodograph is not correct. So, don't just think that because you have that much CAPE, that means that you're going to get tornadoes. It's just, if you want supercells, at minimum, you would need that much CAPE. You could get it less, but I rarely see it, and you definitely could get it more. So that's something to keep in mind with that. But the CAPE here, if we go back up, you can see 1,082 joules per kilogram surface and 1,647 joules per kilogram that's forecasted. But there is a little bit of an issue here. I will admit there is a little bit of an issue, and that is a limiting factor. So if you have a limiting factor, that could prevent thunderstorms from developing. And in this case, it is capping inversion, or cap as we like to call it. And how you can determine cap is by looking at this red line and seeing if it crosses over this dotted line below 3 kilometers, or maybe even below 6 kilometers. It'll be good enough. So if we take a look here, you can see this red line starts out here. Oh, and then it crosses over the dotted line. So right here is where there would be some capping inversion. Now up top, if we just go up a bit further, this isn't capping inversion. This is not a limiting factor. This is just the energy ran out and it's just normally ascending with height. This down here is capping inversion. And so anything in between this red line and this dotted line is capping inversion. And we can actually see how much capping inversion there is by looking at the CINH right here. And you can actually see that at the surface, it's around negative 80 joules per kilogram. Which joules per kilogram, by the way, is just a measure of energy. Kind of similar to volts and watts with electricity, or Fahrenheit and Celsius with temperature. Joules per kilogram is just its own measure of energy. But you can see negative 84, which, if CAPE was around, I'd say 4,000 joules per kilogram and stuff like that, then this much of capping inversion, it could be like half and half. So it could wither away and you could get thunderstorms, or it could limit it completely. But with this little amount of CAPE, this could make or break the system in general. But we still have to keep in mind, because there could be some instances where this cap inversion could be excommunicated and you could still get thunderstorms, which is still possible regardless. So we have to keep in mind with all of that, this capping inversion, that is it going to limit the event, or is it going to nullify it completely? And that's what we have to look at in every event whatsoever, this capping inversion right here. Now, there is one thing that will go against capping inversion, and I did see this on other YouTubers' channels. I'm not afraid to admit it, but I didn't know this actually was a thing as a product on Weatherbell until I saw it, and it's the K-index. And the K-index actually shows the probability of thunderstorms developing. So usually the higher number there is, the more likely thunderstorms are to develop. And so in this case, you can see, actually, let's back it up a bit just to get a general sense as to what it was before and after. So this is Wednesday morning, and you can see across the board, once again, I'm using white Epic pen, lit. You can see right here, mid-20s across the board into southern Kansas and northern Oklahoma. And that's normal for a low pressure pushing on through and, you know, kind of just bringing up moisture with it. Because this Gulf, the Gulf of Mexico, has moisture, and it's going to be pulled up by this warm front that's going to be coming across. So you'll have a nice little warm front that always comes with a low, and you'll have a cold front that's out behind it. So warm front pulls up the moisture. You can see it has the moisture here in Oklahoma, Kansas, Missouri, and it's creating a decent chance of thunderstorms in the morning. But as it continues to move further on into the evening, look at this, starts to get into the 30s. And usually when it gets into the 30s, that's when you have a really good chance of producing a thunderstorm. Because if you think of it this way, you know, I use this for the Storm Prediction Center all the time. You have a 3 out of a 10 chance to try and get thunderstorms, which is actually not bad, because for that giant surface area, that's actually not bad if you create thunderstorms, because if it actually happens, then it spreads around and you get more thunderstorms that way. That's a terrible terminology if you're new to this, but for the people who are kind of like this weather enthusiast-ish, you kind of get what I mean. So 3 out of 10 of that area could get thunderstorms. But then, this is where it gets really interesting, kicks up a notch even further, gets up to 37. 37 is pretty good, actually. You know, usually when it gets into the mid 30s, or actually I'll just say 30s and above, that's when you can start to see general thunderstorms, and maybe even a very good chance of seeing thunderstorms. So, you know, I typically look for, if I were to use the K-index, anything whenever it gets into the red, that's where it starts to get really interesting, and that's where it piques my interest, which is the reason why I've been saying that this event is most likely going to happen, because of what I showed you earlier and how the model trends have been leading up to this event and saying that this very well could happen in northern Oklahoma, southern Kansas. So something to keep in mind with that. But then as it continues to move on through, later on the evening, it becomes more widespread. Possibly could get into Kansas City, southern Kansas City, down into not exactly Norman, Oklahoma, not exactly Tulsa, but Wichita could definitely be impacted by this, and you could definitely see some storms that could form across the board. So that's something to keep in mind with that. Let's go over to the CAPE, convective available potential energy. And I told you all this before, this is a measure of energy in the atmosphere. So on Wednesday morning here, you can see that it's not as much, around the hundreds, but then as it continues to move on through, daytime heating becomes a factor. And what that basically is the sun, when it comes out, it makes the air around warmer. But because of that, it also evaporates a lot of moisture at the ground. So because of that, if you think of it as like steam likes to rise, and it's all pretty moist. You can actually see that steam like on a pot, and it rises. So warm air loves to move up, and that is just you know, that'll happen across much of the areas here. Cool air likes to fall, and the difference between that with that moisture rising up and the cool air sinking is the determining factor as to how much CAPE you have. So you can take a look here. You can already see it's heading up into the upper 700s, and then as it continues to move on through, afternoon starts to get into the 900 frame, and then by late evening hours, not exactly late, I'd say more or less 6 to 7 o'clock, the convective available energy gets up to around 1,000 to 1,200. And usually when it gets into those areas, then you could definitely see some thunderstorms. So there is enough CAPE with this. There is definitely enough CAPE with all of this. The last thing to check with all of this event is the wind shear. And we take a look at 500 millibars, which is just a specific height in the atmosphere. You can actually see along the sides of the sounding here. I'll zoom out a little bit. But you can actually see here on this skew-T diagram where we talked about all the temperatures and dew points and all that such. You can see 1000s right here. I'm using black. You know what? I'm just going to red. Ready? 1000. 850 right here, 700, 500. All those numbers are in millibars. And it's not just a specific spot. So if you see 700 millibars right here, and it's like right next to the 3 kilometers, it will not always be there. It depends upon the pressure and what all is happening around it, which is kind of confusing, but just know that millibars is a specific height in the sky, and we are looking at that to determine what all is happening around here. So as we take a look here, look at this wind shear here, chat. Look at this. You can see there's a plethora amount of wind shear across the board. We'll actually go back a bit real quickly, and you can see that the wind shear in the target area that we're looking at is around the mid 50s to low 60s in knots, and which that would translate to around 60 to 70, maybe 75 miles per hour at this specific height, which is really good for this time of year. Although the shear has been absolutely crazy for this the entire time frame of winter, so we're not really too surprised that it is still continuing that trend here today. But still, the wind shear is relatively quick, relatively fast. So you do have the element of wind shear here. You have the element of energy, not as much energy as you would like to see in specific events, but still you do have energy, you do have wind shear, and you do have some other factors, including a higher probability of producing thunderstorms in those events. But I'll let you guys go. Kept you guys here long enough. If you guys did love the video, please be sure to like it. If you're new, subscribe and hit the notification bell for more content that I provide, whether it's more videos like this or live streams that we do in the actual events. I do live streams when severe weather is occurring, and that actually could impact people's lives. So whenever I do live stream, you're going to want to join me for that. As I said, arguably the best severe weather live coverage on YouTube. Been doing this for a while, and I even did it during Easter, and we had 374 people watching at one point, which was pretty insane because at that particular time period, we actually had the most viewers out of all live streamers on YouTube for weather. So just to keep that in mind, that the numbers don't lie. But anyways, that's going to be it for me. My name is Nate. I also go by Hockey Boy Nate, and I'll see you guys in the next video. Peace.